Hello, this is a quick presentation on the updates of our machine learning slash deep learning project inspired by the Dvorak technique. This technique is used to understand the nature of an emerging storm that is away from the land. When the storm approaches the land or it comes near to the land, we refer to the ground station or the in situ observations mode. But this technique helps us to understand how the consequences of these storms can be, how destructive it can be. The technique mentions of taking satellite imagery that is often visible light spectrum or infrared. Infrared because during the night times details cannot be captured by the visible band sensors. So we take information from both the human visible band and the infrared band, and we assign shapes to what we observe. Each shape can be mapped to a t value. You can see it over here: t 1.5, t2, t3, t4. These values range from 0 to 8 with an increment of zero point 0.5, each being more destructive than the previous one. This chart shows the values when we map the image to a shape. When we select a shape, we come to know the t value of the storm, the of the system. And from the t value or the ci value, the t value is often as same as the intensity number. We can assume that the mean wind speed will be the respective value in knots over here. Now, the mean sea level atmospheric pressure is given in Atlantic region and Northwest Pacific region. I was unable to find this column for the Indian Ocean, but currently we can focus on the Vmax. So that's a progress. Now for our data, we have TCIR data set, which consists of a lot of global tropical cyclones. And if we talk about the Indian Ocean specifically, then we have 75 cyclones, 75 unique cyclones. Each cyclone has 20 plus frames. So you can say 20 plus timestamps. You can see it over here. We have 2003, 05 month, 08 day, 18 hours, then 21 hours, the next day 12 hours, 3 o'clock, 6 o'clock. Hence, we observe that there is an increment of 3 hours over here. Each timestamp has its 4 channel image. You can see this is the infrared, this is the water vapor, this is the visible spectrum, and this is the passive microwave. Now we can see that each channel shows a different variation, a different details of the storm. The technique, Dvorak technique, it considers visible and infrared channels, because this shape mapping is used to happen manually. Now you can see that these shapes can be identified, but you need to be an expert in this. What I am suggesting is that we take all these 4 channels. Sometimes the visible channel and the passive microwave channel might not give us enough details because of night time or some atmospheric phenomena. But what the algorithm we are suggesting is that we take 4 different models. We train each model on a specific channel. So let's say a microwave channel, infrared channel, a visible channel, and a water vapor channel. We take the Vmax or the mean speed, and we can map this Vmax to the Ci value or the T number So what basically our model will be doing is that the model will be taking these four images as the input, with these submodels each being fed one specific channel, and we can predict a t value, or the ci number, based on the average. So even if the details in visible channel are less, or maybe in the microwave channel are less, the other two models will be responsible to give us good results. Now, if I were to describe how we are going to extract the features, CNN models, what they do is that, first of all, we need to define exactly what a shape is. A shape is basically a collection of points, edges, and curves that create a meaningful structure. For example, a circle. Then there could be the numbers from 0 to 9. 0 being similar to a circle, 1 being a straight line, 2 being a complex collection of curves, 3 being a unique curve, 4, 5. So each shape is different than the other. But to the human eye, when we talk about this satellite top view of cyclonic systems, then assigning shapes, as the traditional Dvorak technique mentions, it can be difficult, or it can bring errors. What does CNNs do is that they break down your images or your shapes into the most fundamental or low level features, as I said, lines or the edges or the shapes, and the model trains on this. So the model is indirectly learning these shapes, and when we train it, you can see outputs. We can give output from 0 to 8, and the input being a specific channel of our cyclonic storm. So this is the current idea we have. Thank you.